Hello, welcome to another OSU CyberLab video. To save time and afford diverse presentation perceptions, the voice was generated using text-to-speech in ClickChamp. This video partly explains the intention behind our network architecture. This network design is pretty simple. While a micro-business or home network might have only 2 segments, this set of 5 is still not very complex. Also, this illustration focuses on security stuff. In practice, network segments play a crucial role in performance management and operations. Our segmentation probably does not line up with anyone's real network, but it is useful in introducing cybersecurity concepts. Our hypothetical network architecture emphasizes security-conscious segmentation. We deploy 5 segments. Each has a different purpose and poses different risks. The wide area network, WAN or WAN segment, doesn't have any devices on it. In a more realistic network, a screening router would prevent lots of unwanted traffic from entering through the WAN link. Because the firewall is stateful, a device on our network can reach out to the internet and responses will make it back through the firewall. But inbound connections will be allowed only for specific devices, like our public web server. None of the simulated network is actually exposed. While the Hyper-V host allows us to connect out using Network Address Translation, NAT, the lab environment we set up does not expose any of our devices beyond the host. The WAN link, as we call it, is really only a local interface. DMZ stands for Demilitarized Zone. This is a standard analogy for describing a network segment that allows access to a local network from outside sources. The non-network version of DMZ refers to areas like the buffer between North and South Korea. Gates that open onto the DMZ are guarded and access is restricted. Military units watch that area closely, making it hard for soldiers or anyone, really, to sneak across the border. In network speak, a DMZ is where servers such as web servers, FTP servers, VPN servers, and RDP servers would be positioned. If an organization still has on-prem web servers, they would be here. Increasingly, organizations dodge a variety of threats by letting a company like Microsoft or Google host their email services. Generally, we don't want outsiders snooping around in our networks. But the whole point of the devices on a DMZ is to let vendors, customers, employees, or other outside partners access selected IT services. If connections were not allowed in from the internet, the services would be useless. We need to carefully watch the servers that live in the DMZ. Because they are exposed to outside influences from the internet, they could be misused in attacks against our internal resources. First, we harden them by closing off services and ports, uninstalling unnecessary software, and making sure the systems are up to date. Firewall rules will generally block devices connected on the DMZ from initiating conversations with other internal computers. Of course, some exceptions will be applied, and traffic monitoring in the DMZ is a must. In short, the purpose and function of DMZ devices is known. Rules can block unexpected messages into or from the DMZ. The details of how messages are received and routed to the right server in the DMZ are outside the scope of this lab. Today's workplaces are technically diverse. There is often a battle of sorts brewing between workers who want maximum flexibility and minimum friction and security people who want to keep their free-spirited flock safe. Some organizations, banks and the military for example, need to keep things buttoned up. They whitelist selected software allowed on computers, and they don't allow regular users to install anything anyway. They limit access to internet resources. They don't allow personally owned devices on the network. These things all help keep the organization and people safe from cyber risks. But even then, a variety of devices and workflows are deployed. In today's world, you have to interact with the internet to get things done. User workstations are the main thing here. But while Internet of Things IoT devices, perhaps including printers, door locks, voice-over IP phones, VoIP, smart thermostats, smart cameras, and more, may well be segregated onto separate network segments, for our purposes in this lab, we will put all the stuff together on the OfficeNet segment. Other segments will be more regimented to protect high-value resources. Here we may just let a few things go so that the IT folks don't have to handle even more support tickets when some new whiz-bang program or device is added. One key risk for most organizations is having data stolen or damaged. Cyber baddies either want to help themselves or hurt you. Common cyberbad strategies include expose private data to embarrass or worse, steal secrets to make money, encrypt valuable data and make someone pay to get it back, disrupt operations. And the not-so-baddies can cause problems too. Insiders can make mistakes that have unexpected consequences. But if their computers can't directly communicate with high-value devices, they pose less risk to the services those devices provide. As in the DMZ, the IT team should know just what high-value systems such as database, storage servers, and internal-only web servers do. Whereas in OfficeNet, we have to expect some unruly messaging. Only known traffic is allowed on SecureNet. These devices hold the crown jewels, so we protect them with all our might. All these segments and all the network protections depend on having properly configured networking devices. We want to carefully control access to the management consoles of these devices. You'll hear it all the time in cybersecurity podcasts. Don't expose management consoles on the internet. Good advice. If someone can talk to your router's configuration service from across the world, you are vulnerable. Numerous breaches every year could have been avoided by limiting access to core network gear. Of course, you hope good authentication and hardened applications would block unauthorized activity. But why take on more risk than you need to? This idea should be extended as networks grow. Why let messages from the DMZ reconfigure your routers, switches, or firewalls? Those devices might be compromised. Why take a chance that a compromise of a regular user's machine, a mistake, or a disgruntled user will damage your network? Our ManageNet segment illustrates implementation of this common-sense proposition. Organizations create special network segments for managing gear. Only selected devices are to be connected on ManageNet. Usually that means computers on IT administrators' desks. A privileged access workstation, PAW, might be used only for network management tasks, not word processing, not email. This substantially reduces their attack surface. And the management consoles for network gear are only exposed on ManageNet.